Hi everybody, happy Wednesday. For our lesson today, we are going to talk a little bit more about proving triangles similar. Just like when we covered congruent triangles, we had some shortcuts that we used to prove triangles congruent. And we're going to have shortcuts that allow us to prove triangles similar. So the first shortcut we're going to be taking a look at in the lesson for today is called angle-angle similarity postulate, or AA for short. So it says that if we have two angles in one triangle congruent to two angles in another triangle, then the triangles are similar. So because I know that angle A is congruent to angle Y and angle B is congruent to angle Z, so I have two pairs of congruent angles in the two triangles, I can say that the triangles are similar. So I'm going to want to write a similarity statement, and just like when we were writing congruency statements, order of the letters matters. So I can name the first triangle any way I want to. So maybe I go ahead and name that triangle ABC. So I started at the vertex with 2 arc marks, moved to the vertex with 1 arc mark, then finally the vertex with no arc marks. So when I go to name the second triangle, I want to make sure that I go in that same order. So I want to start with the vertex with 2 arc marks, move to the vertex with 1 arc mark, and then end with the vertex with no arc marks. So the lesson for today, we're only going to be taking a look at angle-angle similarity. So the first example that we're going to look at here says determine whether the triangles are similar. If so, write a similarity statement and explain your reasoning. So I want us to decide whether the small triangle and the large triangle here are similar to one another. If it helps you to use some colored pencils or highlighters to outline the two triangles, you can definitely go ahead and do that. These little arrows mean that I have two parallel segments. So I know that because I have a parallel segment and a transversal, this angle and this angle would have to be congruent. So remember when we talked about parallel lines, these angles in the corner of it's making like a letter F on its side, in the corners of the letter F fall a pair of corresponding angles. So I know that angle U is congruent to angle SLT. I have to use 3 letters for this angle because there are multiple angle L's because of corresponding angles postulate. I could also say that this angle and this angle are congruent by corresponding angles postulate. But the other angle that I want us to just take a look at is in the small triangle, we have angle T falling inside of it. In the large triangle then, we also have angle T falling inside of it. So I just want us to be aware that these two triangles share an angle. So angle T has to be congruent to angle T because it falls inside of both the small triangle and the large triangle. And just like our last unit, that's because of the reflexive property of congruence. So I've proven two pairs of angles congruent in the two triangles. So I'm ready to say that I have similar triangles. I just want to make sure that when I name them, I go in the same corresponding order. So maybe I go ahead and name the first triangle TLS. I go from 2 arc marks to 1 arc mark to no arc marks. So when I name the larger triangle, I still want to go from 2 arc marks to 1 arc mark to no arc marks. And the triangles are similar by angle-angle. For part B, we are given that angle B and angle D are congruent because those arc marks were placed for us in the diagram. So that's one pair of angles congruent. If I want to prove the triangle is congruent by angle, I need a second pair of angles congruent. So I do have a pair of vertical angles. So I'm writing basically the statement and the reason on the other side, kind of like a proof, but not in the proof format. So I've proven two pairs of angles congruent. I'm ready to prove the two triangles congruent. I decided to name the first triangle BCA, going from 2 arc marks to 1 arc mark to no arc marks. So when I name the second triangle, I want to go in that same order, and they would be similar by angle similarity as well. We're going to do just a couple more examples here. So part C, we have two triangles. We're given some actual angle measures. So I'm given a 60-degree angle, an 81-degree angle in the first triangle. I'm given a 40-degree angle and an 81-degree angle over here. So obviously, angle B is congruent to angle E. Again, that's basically given to me because 81 is congruent to 81. But 60 and 40 are not congruent. So I want to use triangle sum theorem to figure out what this angle is. So I want to take 81 and 60, take their sum, subtract it from 180, which is going to give me 39. If I take 81, 40, add them together, take away from 180, I'm going to get that angle F's measure is 59. So in this example, I'm only able to prove one pair of angles congruent. Because I'm unable to prove a second pair of angles congruent, the two triangles are not similar to one another. And then for part D, I see that I have one pair of angles marked up, but I'm given no other angle measures. What I'm actually given is that I have a pair of sides congruent and then a second pair of sides congruent. So a little bit of review from our last unit. I could actually say that triangle STU is congruent. I know that's not what I'm asking here, but we'll see how it ties in just a second. I could say that that triangle is congruent to the second one. And that's because of side angle side. I have two sides and an included angle. And we talked about yesterday how all congruent triangles are similar. So anytime we have a pair of congruent triangles, they are always similar. So I know that triangle STU, if it's congruent to triangle XVW, it also has to be similar to that triangle. For the next couple of examples, I want us to determine whether the triangles are similar or not. And then if they are, I want us to write a similarity statement, and then I want us to find the values of the variables. So again here, I'm given a pair of parallel segments. So I could mark up that angle B is congruent to angle D. If we highlight the two parallel segments and a transversal, it's making that Z or N shape. So remember that those are then a pair of alternate interior angles. So angle B would be congruent to angle D because of alternate interior angles theorem. I could also make a Z the other way though, using AE as the transversal. So I could say that angle A is congruent to angle E also because of alternate interior angles theorem. So that's one pair of angles, two pairs of angles. You could have, though, said we have a pair of vertical angles, so that wouldn't have been wrong if you instead used the pair of vertical angles for your second pair. So I then know that triangle ABC would be similar to triangle EDC, starting in each triangle from the 2 tick marks to the 2 arc marks to the 1 arc mark to 0 arc marks. And they're similar by angle. The new part of this is that what I want us to do now is find the values of X and Y. So in order to do this, in order to find side lengths, remember that side lengths are proportional in similar figures. So I want to set up a proportion comparing corresponding sides. So we did this a lot in yesterday's lesson. So I know that AB corresponds to ED. I know that BC, last 2 letters, correspond to DC, last 2 letters. And finally, AC, first and last letters, correspond to EC, first and last letters. So now I'm going to go into the diagram and substitute in the numbers and variables that I have for all these side lengths. So if I look in the picture, AB has Y next to it. ED has 7. BC is 2. DC is 3. AC is X. And EC is 5. So I know that all of these ratios should be equivalent, or the ratio that's first and the ratio that's last should all simplify to 2/3. So I'm going to kind of break this out. Instead of comparing like 3 ratios at a time, I'm just going to compare 2 at a time. So I know that whatever Y/7 is, it has to simplify to 2/3. Now, what I'm going to do, because I think using equivalent fractions is going to be a little bit harder here, because you can't easily tell what do I need to multiply 7 by to get to 3 or vice versa, I'm just going to go ahead and cross multiply. So my one cross product, I get 3y. The other cross product, I get 14. If I divide both sides by 3, y is going to end up being a fraction. So 14/3. Then I need to still figure out what x is. So now what I'm going to do is take the 2/3, set it equal to x/5, use this proportion to figure out what x is. So again, I'm going to cross multiply. So my one cross product, I get 3x. The other cross product, I get 10. If I divide by 3, x is equal to 10/3. So we do have some fractions or decimals here. And then the last page, we're just going to take a look at a couple more examples. So determine again if the triangles are similar. If so, write a similarity statement and find the values of x and y. This one is just going to have an x, not a y. Same with this one.